Everyone, I am Kishore Prabhakar and I am studying my first year of Information Technology at V.S.B Engineering College, Autonomous KARUR. So in this video, we are going to see about a GPU. What is a GPU? A GPU is a graphics processing unit, and a GPU is not so familiar like a CPU. We all know about a CPU but not about the GPU. So there are differences between the CPU and GPU. Differences between CPUs and GPUs are classified into three categories, mainly architecture, performance and usage. In terms of architecture, a CPU is basically designed to handle a large amount of tasks but a single task at a time. A GPU is not the same. A GPU is designed to carry forward graphics based tasks, which are small simple tasks but multiple tasks at a time. To understand this, let us see the two-man analogy. A two-man analogy is that there are two kinds of people. A person who is very strong can carry heavy weights, but he can carry only one heavy weight at a time. But this is not the same for a large number of weak people. If you have weak people, they can carry small weights, but as there are many people, they can carry lot of small weights. While comparing this to a computer, a CPU is the powerful but can handle only one task at a time. A GPU is not as powerful as a CPU, but it can handle multiple small tasks at a time. A powerful task is like interpreting a program, and a small task is like knowing what calculations to make and what graphics to display. A GPU can calculate the LED's color to display in your monitor, but a GPU can also do that, but as it is a very small task, it cannot handle one small task at a time. This will be very power inefficient. Speaking about the applications of GPUs, we have four main applications of the GPU. First and foremost, it is about the graphics rendering. A GPU is used to smoothly render your graphics for games, simulations, virtual reality and animation. And second of all, it is machine learning. In machine learning, GPU is used to accelerate the process of deep learning. And finally, cryptocurrency and scientific computing are small but very important tasks of a GPU. In cryptocurrency mining, if you use a GPU, it will help us boost the mining process to find crypto tokens. And finally, in scientific computing, take the example of scientists, especially NASA or ISRO scientists, generating or simulating a world which is similar to a real world. Let us say they want to launch a rocket to space. They need to do all the calculations, and for that they can't go to space and do the calculations. For that they need to simulate the space and they need to do the calculation. To simulate such a vast space, a CPU's power won't be sufficient. So we need the help of a GPU. Let us see about the advantages of using GPUs. GPUs help in three most things: high performance, energy and parallelism. High performance of a GPU can help in producing high quality graphics, and it is also very energy efficient compared to using a CPU. And finally, parallelism. Parallelism is that it can do multitasking and can handle large amounts of graphics rendering at a time. And the disadvantages of using a GPU is that GPU can handle only specialized usage. For example, if we don't give GPU the task it is assumed to do, then it will be a waste of time, waste of energy and a waste of effort. And GPU involves cost and complexity. GPUs are not cost friendly, and installing a GPU can be a financial burden. Finally, heat and power consumption is also considerable. Thank you so much. Thanks for listening.